In this demo, we'll configure Ether channels between Cisco switches. In the exhibit, we have 3 Cisco switches, switch A, B, and C. Switch A and B are considered access switches. They will serve as endpoints, workstations, IP phones, and stuff like that. They are access switches. They both have dual redundant connections up to a parent distribution switch, which is switch C. Redundancy is good. If either one of those connections upstream went away, the other one would still be able to carry all traffic between access and distribution. By default, dual connections like this would create a loop in the network, and spanning tree would block one of those connections. Even with redundant links upstream, you'd still only use 1 gigabit of throughput. What Ether channel technology allows us to do is bundle those 2 connections together so that they're seen as one 2 gigabit per second circuit with twice the speed. With Ether channel technology, both links are used and you get higher bandwidth between the switches. The 2 connections operate as a single link. Spanning tree doesn't block either connection. In this demo, we'll configure the 3 switches and use a negotiation protocol called PAG-P, or Port Aggregation Protocol. This protocol is Cisco proprietary. If you're connecting to non-Cisco switches and wish to use Ether channel negotiation, you must use the Link Aggregation Control Protocol, or LACP, instead. We'll look at the 2 interfaces on switch A. First, let's enter Show Run Interface G01. We see that Gigabit Ethernet 01 has no config. It's in its default state right now, so that's good. We'll verify the same on Gigabit Ethernet 02. It's the same. Now, we haven't done anything with this switch yet, and we're ready to start our Ether channel configuration. We'll enter Interface Range. This command will allow us to modify more than one port's settings at a time. Otherwise, we would have to go into each interface and execute the series of commands on each one individually. We'll use the Switch Port Mode Trunk command to manually set these interfaces to trunks. You might be aware that switches often automatically negotiate trunk connections. In this case, we'll take charge and manually configure the interfaces. Now we're ready to begin the Ether channel configuration. We'll type channel group and add a number that indicates the channel group for this series of interfaces. You can use any number you want. We'll type 1 as this is the first Ether channel we're creating. Then type mode. We have several options here. We mentioned using PAG-P. You can see we have 2 choices for PAG-P, auto and desirable. We'll type desirable. Choosing desirable indicates the interface is taking an active role in Ether channel negotiation. At least one side must choose desirable. If you had both sides at auto, which is more of a passive role, then the channel would not get settings negotiated. We press enter, and the port channel has been created. Alright, that's all we have to do. We enter end, and then enter a quick write. We'll enter show run int G01 to show the config of both of those interfaces. You can see the interface range command worked. Okay, we're done with switch A. Now let's do the same series of steps on switch B. We'll telnet to switch B, log in, and go through the same series of commands, for the most part. Enter config T, and then enter interface range. This time, we'll use channel group 2 because we want to make the channel groups consistent on the parent switch, switch C. The channel group that leads from switch C down to switch A will be 1, and this channel group will be 2. The numbers that you use for the channel groups are more for documentation purposes, so they really could be anything. Again, we'll use mode desirable. We'll enter that command, and now we're done with switch B. We'll pop out to the parent switch A. Then we'll telnet into switch C. Now this should look familiar. Enter config T, and using range, we'll configure 2 ports at a time, not all 4, and you'll see why in just a second. Enter int range G01 2. Enter switch port mode trunk to set to trunk. We'll use channel group to match what we did on switch A. Let's enter channel group 1 mode auto. We use mode auto, the passive negotiation mode. Remember, you set the other side to desirable, so as long as one side takes charge, negotiation will occur. After a bit of a pause, we see that we get our prompt back. Now we can continue with the configuration of the second Ether channel. Enter int range G03 4. Enter switch port mode trunk. Then type channel group 2. This matches the Ether channel that we configured on switch B. We'll make this mode auto as well, so we add mode auto and press enter. Okay, we should be done here. Let's end out and save our work. We'll enter show run and look at those ports. We can see it's configured as a trunk and the channel group has been set to auto for PAGP negotiation. Now, to further verify the work, we can enter show Ether channel summary. We see that we do have two Ether channel groups up currently. We have port group 1 and port group 2. Let's take a look at the codes here. We have an SU for both of those. S indicates it's a layer 2 or switched port channel. We can also create layer 3 or routed port channels. We can see the negotiation that was used to bring the port channel up. Finally, we see that the physical ports have been added to each of these port channels. So, success! In this exhibit, we have two switches, switch A and switch B. You can see that there are 4 redundant connections between the two using fast Ethernet 0, 1 through 4 on both switches. As it turns out, switch A in this example is not a Cisco switch. You can create Ether channels between Cisco and non-Cisco devices, but we can't leverage Cisco proprietary protocols because it's not a Cisco switch. If we want to use a negotiation protocol for this Ether channel, we need to use LACP. We'll make sure that when we configure switch B, all interfaces are operating in full duplex mode. Switch A has already been configured, so we have to configure switch B. Let's go into global config. We'll enter int range F014 command to grab all 4 of those interfaces. That will take care of the duplex requirement right away. We'll enter duplex full, which means the interfaces can send and receive at the same time. We'll configure them all manually as trunk connections. Then we're going to type channel group and include a group number. Again, this can be anything unique to the switch. If the exam gives you a channel number to use, make sure you use that number. We'll type 6 and type mode. You need to tell it what mode of negotiation this Ether channel will use. Let's look at the options. We know we can't use PAGP because that's Cisco proprietary. We have 2 options for LACP. One is active and the other is passive, so they're pretty self-explanatory. Active means that this switch will take charge of negotiating for that Ether channel settings, and passive means that the other side will wait for the connected switch to take charge. If you have both sides set to passive, then no negotiation will take place. We'll make this side active, so it will take a leading role in configuring the Ether channel. That's all. The port channel has been created. We can end out, and save your work, of course, by entering write or copy run start. That's it for this demo. In this demo, we configured Ether channels on Cisco switches.